Hey guys, welcome back to the YouTube channel, and today we'll be finishing off polar coordinates by talking about complex numbers in polar coordinates. Let's get started. A complex number equals a plus bi. But let me show you this. Hold on for a second. This also equals r cos theta plus r sin theta I. Now, you're probably wondering how we got here. Well, on the previous video, I drew a Cartesian plane of the xy grid with a radius length right here. We knew that x equals r cos theta and y equal r sin theta. We could easily replace x and y with a whole different system, the complex number system, with a and b. A equaling r cos theta and b equaling r sin theta I, because this is an imaginary coefficient and this is a real coefficient. From here we could factor out the r bracket cos theta plus sin theta I. Now, a complex number, this would now equal something we call r cis theta, which is a form that we will use in polar coordinates, r cos I sin theta. Now that we know r cis theta, I have a question for you. So we have 4 plus 5i. This is a complex number. I want to find the polar form of this complex number. We need to get it into this form as the end result. So we got to find out how. I know that we can find r by doing root a squared plus b squared, and that we can find theta using inverse tan over b in a. This really isn't any different from the previous video when we were using x's and y's. We're literally just using a's and b's. So to calculate for r, this equals root 4 squared is 16 plus 5 squared is 25 equals root 41. Let's underline that because that's what our r value is. Now to find theta, theta equals inverse tan multiplied by, let's see, 5 over 4. Our theta value will equal 51 degrees. We got theta and we have r. We could put this into the complex number form. Our final answer, the complex number, equals root 41 cis 51 degrees. Let's box out our answer, and there we have it. So instead of finding the polar form of the complex number of now I want, instead of finding the polar form of a complex number, now we're trying to find the rectangular form of a complex number right here. Z equals 4 cis 30. How do we solve this exactly? Well, let's look at it for a second. This is practically r cis theta. If we were to expand it a little bit, we would have a equals r cos theta and b equaling r sin theta I. This is because cis contains cos I and sin. Therefore, we know this is r and theta. We could just plug it in to a and b to have our end result of a plus bi. 4 cos 30 equals, and 4 sin 30. I did the math and our answer comes to 3.46, 2i. This is how we put complex numbers into rectangular form. Close bracket. To wrap things up, a little review. We learned that complex numbers are very similar in terms of equations correlated to a, bi, and x and y. We learned how to take the complex number and convert it from rectangular to polar, vice versa, with the help of r cis theta, which is something very new. Well, unfortunately, this is the end of polar coordinates. We are moving on to our final topic, matrices. Tune in for that. It's coming in next video, probably 5 minutes right after I upload this. If you liked the video and enjoyed it, please spank that like button and subscribe. Peace.